The first question I gave you was number 6. I don't know what to say. You can as long as you don't talk. All right. Number 6. Please pay attention. You are given f of x equal to 2x plus 3 all squared divided by the cube root of x. All right. Now the first thing is I have told you during the past few days, if you want to find the derivative, you need to remove the brackets, you need to remove the division line, you need to remove the square root signs. So here we have got brackets, we have got a root sign, we also have a division line. So to do that, we use FOIL in the numerator. So it will be 2x plus 3 times 2x plus 3. This is all over. Now, the denominator can be written as x to the power of a third. The denominator can be written as x to the power of a third. Now, this is coming from your grade 10 and your grade 11. Alright? Then if you use FOIL here, it will be 2x times 2x, which is 4x squared. 2x times 3, that's 6x. Then 3 times 2x, that's another 6x. If you add the 2, you get 12x. Then 3 times 3 will give you a 9. Alright? Now, we still have got a problem. We have got a division line. Now, to remove the division line here, we divide each numerator by the common denominator. I'm sure you can all see here that the common denominator here is x to the power of a third. Alright? Then, okay? Then, the next thing, we are going to divide each numerator by the common denominator. Like that. Okay? The reason why we are doing this is for us to apply the first law of exponents and the other exponential laws. Right? So the second law of exponents. So here we have the same base. I hope you can see that we have the same base here. So we can subtract the exponents. Also here, we have got the same base. Now here we have got that x to the power of a third as part of the denominator. So here it will be 2 minus a third. Now 2 minus a third will give you 5 over 3. So this will become 4x to the power of 5 over 3. If you are dividing terms that have got the same base, you subtract the exponents. So 2 minus a third will give you 5 over 3. Right? You can use a calculator if you can't do it mentally. Then here, 12x, the x has got an exponent of 1. So 1 minus a third, it will give you 2 over 3. So you get 12x to the power of 2 over 3. Then, to simplify this x to the power of a third, we use this exponential law. X to the power of n is equal to 1 divided by x to the power of positive n. Okay, so we will get plus 9x to the power of negative a third. So this is now our f of x. After removing brackets, removing division lines, and removing the root signs. Generally, in an examination, you get 1 mark for simplifying up to this point. This is not the derivative, because I haven't used rules yet. Now I'm going to use rules, so it will be f prime of x will be equal to 5 over 3 times 4. That will give us 20 over 3. So this becomes 20 over 3x. Then I'll subtract 1 from the 5 over 3. Again, be aware that you must use your calculator if you can't do it mentally. So this is the same as 5 over 3 minus 3 over 3. So that will give me 2 over 3. Then 2 over 3 times 12. That will give me 8. Because 12 times 2, that's 24. 24 divided by 3 will give me 8. Then I have to subtract 1 from the 2 over 3, so I'll get minus a third. Then minus a third times 9, that 2 give me minus 3. X, then I have to subtract 1, so I'll get minus 4 over 3. Okay, so this is the derivative, right? You can convert the negative exponent to positives, but it's not that necessary. Okay, you get your full marks up to this point. So the mark allocation, it will be 1 mark for that expression for eliminating brackets, root signs, and division line. Then 1 mark to find the derivative of the first term, another mark the derivative of the second, the third mark for the derivative of the third term. So in total, a question like this can have 4 marks. Right? And please expect questions of this type in your June paper. Okay, your paper 1, expect questions of this type. All right, any question? So if you did the work, just mark your work, correct yourself, see where you went wrong. That's the good thing about having done the questions. All right, please allow me to carry on because of time. All right, then the next question was number 9. Number 9, we're given h of x is equal to minus x squared plus 3x plus 4 all over 2x plus 2. Now, it's very important, can you pay attention? It's very important for you to know that some questions on finding the derivative using rules, they require you to factorize. There is no need to have an increase in heartbeat to see a question like this. Okay? If you see a trinomial or a binomial, remember your factorization. That's the reason why you did factorization in grade 9, grade 10. It was also to prepare you for calculus. You need your knowledge of factorization in calculus. Okay? So here, our numerator, first, I'm going to factor out minus 1 in the numerator because the coefficient of x squared is a negative 1. I want to make the coefficient a positive 1. So I'll take out negative 1, and I'll get in brackets x squared minus 3x minus 4. This is all over. Now, the denominator has got a common factor, which is what? A 2. So this will be 2 times x plus 1. Now, the moment you get a binomial factor like x plus 1 there, that should be a hint to you that in the numerator somehow you might need to create a factor which is the same as x plus 1. Okay? So if I factorize the numerator, I'll get minus. Now this will be x minus 4 times x plus 1. Okay? This is all over 2 times x plus 1. Okay? Then those two obviously are going to cancel out. This cancels with that. Okay? In the end, we are going to have minus in bracket, sorry, outside bracket x minus 4, of which I can distribute this minus a. Okay? Because I want to simplify and then find the derivative. This is not the derivative because I haven't used any of the rules yet. It's not the derivative. It's h of x. Okay? So, on the next page, I can write h of x is equal to minus x plus 4 all over 2. Then, since we have a common denominator there and we have a division line, we need to remove that division line in order to find the derivative. So this would be the same as minus x over 2 plus 4 over 2. Okay? Now, it's important for you to know that minus x over 2 is the same as minus a half x, and then 4 over 2 is the same as a 2. That's not the derivative yet. Okay? And what type of a function is this? It's linear. And what did I say about the derivative of a linear function?
So what, sir?
What did I say about the derivative of a linear function? It's what? Thank you. Thank you. So our answer here is h prime of x will be the coefficient of x. That's our gradient. So that will be minus a half. You don't have to think or even to use rules if you get a linear function, because the gradient of that linear function is equal to the derivative. By now, you should know or understand that gradient is the same as the derivative. It's the same. Okay? It's just that the word derivative, it's a calculus term, or it is the word used in calculus for gradient. Okay? So this will be our answer. The derivative of a linear function is always the gradient of the linear function. Okay? Let's move on. Then I gave you number 2 here. So we have got d over dx of p times square root of x plus 5qx squared plus r over x. And we are told that p, q, and r are constant, which means they are real numbers. Okay? Now here, we have got a special type of notation which I told you is d over dx of an expression. So with this expression here, you can just write your answer straight away. That will be your derivative. But before you write the answer after using rules, you need to eliminate square roots. You need to eliminate division lines. So we have to eliminate the division line here. We also need to eliminate that root sign before we find the derivative. So this will be d over dx of px to the power of a half. By now, you should know that the square root of x is similar to x to the power of a half plus 5qx squared, then that one becomes plus rx to the power of minus 1. Okay? Right? So it's 1 mark to get that expression. Removing the root signs, removing the division line. Now I can use rules. So this will be a half times p. So I'll get a half px. Then I'll subtract 1 there. I'll get minus a half. Then here it will be 2 times 5q. That will be positive 10q x to the power of 1. So I can just write this as qx. Then the third term will be minus 1 times r. That will be minus rx to the power of minus 2. Because we subtract 1 from there. Okay, so this will be the answer. So again, you get 1 mark for that expression, 1 mark for the derivative of the first term, second mark, derivative of second, third mark, the derivative, or rather fourth mark for the derivative of the third term. So total what?
So,
4. Yes.
are we supposed to leave our answers with negative exponents?
Yeah, you can leave your answer with negative exponents. But as I said, sometimes you can convert it to a positive exponent. But you see that generally when you write metric, they won't specify that leave your answers with positive exponents. So you can leave your answer like that, yes.
And so, can you, for this one, so half px to negative 1 over x, can you put it as 1 over 2p over x, or the square root of x?
Yes. Which means what you are saying in terms is that what you are saying is you can the answer here, if I remove the negative sign, if I convert the negative exponent to positive, this is going to become p divided by 2 root of x. Right? That one remains as it is, 10 times qx. So this will be 10 qx. This becomes minus r over x squared. Okay? But be aware that there won't be that strictness, okay, of converting negative exponent to positive. If you stop where I put the tips there, you deserve full marks because you would have used the rules. Generally, that the mark is not given, or the final mark is not given for knowledge of exponents, but it's given for knowing how to use the rules of differentiation. Okay?
Yes.
If you look at your textbook, the latest edition of Mind Action series, it doesn't convert negative exponents to positives. Right? Okay, then number 6, we have an equation from physics here. Right? Equation of motion. So we have got S equal to ut plus half at squared. So u and t, they are constants. For those of you who do physical science, you know that u is the initial velocity and a is the acceleration, and they are constants. Okay? So if you want to find the derivative here, it's very straightforward. There are no division lines. This half here, it's actually a coefficient. Okay? So this will be s prime of t is equal to, now the first term is linear. The derivative of a linear is equal to the gradient. So this will be u, right? Then this is quadratic, so it will be 2 times a half, which is 1, times a, you get positive a. Then you subtract 1, you get that. Now, I'm sure if you do physics, you know that this is equivalent to the velocity. Okay? The gradient of a displacement function is velocity. Okay? Right. Okay. But we are not going into the physics, but you have to know that to understand mechanics, you need mathematics and you need calculus as well. Okay? But your curriculum in physics does not involve a lot of calculus, or it's not their problem. All right. Are you following that? So this will be the answer. And by the way, you can also, we are going to talk about derivatives of equations of motion later on, okay, when we do application of calculus. You can be tested in math, questions like this, right? Then, I also gave you number 2. Please make sure you pay attention as I do number 2. So number 2, you have got 3y minus xy equal to x to the power 4 minus 9x squared. Right? Now, I'm sure you can see that we have got 2 terms here that have got y. I'm sure you can see. We have got this term, and we have got that term. Now, if you want to find the derivative, you are only supposed to have y as the subject, which means in this question here, we have got a problem. We have got 2 terms that have got y. So we need to factor out y, and then make y the subject. So the first step is to factorize the left-hand side, okay? And then you get x to the power 4 minus 9x squared, right? Then we divide both sides by 3 minus x. So this becomes y equals x to the power 4 minus 9x squared over 3 minus x. Okay? Now we're almost there. But the problem now is we've got a division line. So we can take out the common factor, which will be x squared. Okay? Our denominator, we can swap the 3 and the minus x, so we get minus x plus 3. The reason why I'm doing that because I have seen that this binomial is a difference of what? 2 squares. Remember when you first took difference of 2 squares? You work them out. Okay? So this will be equal to x squared times x plus 3 times x minus 3. This is all over. Now this, I can factor out minus 1 and get minus x minus 3, like that. So that this term here, and that, or rather that factor and that factor, they will cancel out. So my denominator is going to be minus 1, which means my expression after factorizing and simplifying is going to be y equal to minus x squared times x plus 3. Okay? I've taken into account this minus here. So x squared minus 1 gives us minus x squared. following? Right, then we need to remove the brackets. We don't want brackets. If we are to find the derivative, we don't want the brackets. So, on the next page, if I multiply minus x squared times x, I'll get minus x cubed. So this will be y equal to minus x cubed minus 3x squared. Now I can find the derivative. It will be dy over dx. So that will be minus 3x squared minus 6x. Then like that. Okay? Are you following? Yeah. After this lesson, you would have been prepared for the June exam on rules. Okay? On rules, on this part of rules. Yes. Okay. Can I have it? Remember I told you it's a very long, it's the longest topic in maths. Over 40 marks in calculus only. Okay. Right. Okay. And then the last question, which I also gave you, right? Last question. I asked you to do number 2. Right? Please pay attention. Pay attention. I asked you to do number 2. Okay? Now, sometimes you may be given two functions and you're supposed to find a derivative which is related to both functions. That's the case here. Okay? What do I mean by that? Well, if you look at the first function, okay, it's y equal to the square root of x plus x. Obviously, I don't want the root, so this becomes x to the power of a half plus x. Alright? Then you have the second function, which is x, which is x equal to t cubed. Right? Okay? Now, that one is already simplified. So if I want dt over dx, I have to use both functions. So I'm going to find dy over dx here. So dy over dx will be equal to a half x to the power of minus a half plus 1. Okay, remember the x is linear, the derivative of a linear is the gradient. The coefficient of x here is a 1.
So aren't we using dt over dx?
Uh-uh. This is not the answer. I'm getting to the answer. Okay? Right? Then, for this one here, it will be dx over dt. That will be equal to 3t squared. Alright? Are you following that? So we are going to use the derivative. Okay? So if I want dt over dx, I need to use, if I look at this and that, the only way that I can create dt over dx, okay? You see this y here, we have got the y. Now, if you look at it, we don't have y there. Do you see that? Do you see that?
Yes.
There is no y. So we have got dy. So if I want to find dt over dx, I just have to swap these two. Are you following that? Yeah, which means dt over dx is going to be dt over dx. Just swap these two. Then leave my derivative with 1 over what? At squared. Now, there are times, I think this one here, let me do that one. Okay, I'll do this one as well. Are you following? So this was the solution for number 2. This one here. That will be number 2. This is the answer. Yes.
Why did you say dx over dt? It's not just right to
No, you can't directly get the derivative dt over dx. You have to find dx over dt first. Then you swap the numerator and the denominator. Obviously, I'm sure you are aware that the denominator there is a what? It's a 1. So you just swap the numerator and the denominator, then you get your dt over dx. Then here it becomes 1 over 3t squared. Okay, so we haven't used this one yet. But if we want to answer number 3, okay, dy over dt, right? That one now is going to be equal to, I'm sure you can agree with me that if I multiply this dy over dx by dx over dt, I'll get dy over dt.
No, but I'm not sure.
Can you pay attention? Dy over dt is the same as dy over dx times dx over dt.
Yeah.
Do you see that?
Yeah.
So that these two will cancel out. Are you following that?
Yes.
So my dy over dx there is half x to the power of minus a half plus 1. Then my dx over dt is 3t squared. So that will be times 3t squared. And my final answer, okay, can you pay attention? Can you pay attention? What I'm trying to say is, if you want to determine dy over dt, is there, okay, in this equation, do we have a relationship in y and t together? No. Do we have a relationship in y and t there? No. So what we have to do is we have to use the derivatives of both of them to come up with dy over dt. And the only way you can do that is to multiply dy over dx by dx over dt, because this dx and that dx, they cancel out. So we just have to multiply the two derivatives. That is dy over dx and dx over dt. If we multiply those two, we will get dy over dt. Okay? So the final answer here is going to be, well, if I multiply, which means I might need to put a bracket there. Okay? Yes. I need to put a bracket there because that's a binomial. So I'll get 3 over 2 x to the power of minus a half times t squared plus 3t squared. So this will be my final answer for d1 over dt. Please take note that x and t are not like terms. Okay. So this will be the end of rules of differentiation. Okay? That will be the end of rules of differentiation.